Imagine a massive asteroid, the size of a football stadium, hurtling toward Earth. Astronomers have spotted it too late for a gentle nudge. There's no time for multiple spacecraft missions. The clock is ticking and millions of lives hang in the balance. What's our last line of defense? The answer might sound like a Hollywood movie plot. Nuclear weapons, but unlike Armageddon, real scientists aren't sending Bruce Willis into space. They're finding ingenious ways to test this controversial approach right here on Earth. Despite what many assume, asteroid impacts aren't just ancient history. Each year, thousands of space rocks pass near Earth. With about 25,000 city-killer asteroids, those over 460 feet long, estimated to exist in our neighborhood, scientists have only tracked about half of them so far. While the daily odds of impact remain extremely low, the consequences could be catastrophic if one struck a populated area. That's why planetary defense researchers are working tirelessly on multiple protection strategies, including options that were once considered pure science fiction. While gigantic dinosaur-killing asteroids get the most attention, it's actually the mid-sized city killers that pose the greatest current threat. These space rocks, measuring upwards of 460 feet long, could devastate entire metropolitan areas upon impact. Scientists estimate about 25,000 of these dangerous asteroids exist in Earth's vicinity, with less than half currently identified and tracked. If one struck a populated area, the devastation would be catastrophic. An enormous blast wave similar to a large nuclear detonation would instantly turn solid objects into fluid, leaving homes demolished for dozens of miles. Though astronomers constantly scan the skies for new near-Earth objects, a significant percentage remain undiscovered. This surveillance is our first line of defense. Early detection provides crucial time to implement deflection strategies. The more time available, the more options we have for preventing disaster. The simplest approach to asteroid deflection is essentially a cosmic game of billiards. In September 2022, NASA's Double Asteroid Redirection Test (DART) mission successfully demonstrated this method by deliberately crashing a small spacecraft into an asteroid called Dimorphos at 14,000 miles per hour. This kinetic impactor transferred its momentum to the space rock, altering its orbit around a larger asteroid named Didymos. The mission proved that humanity can physically change an asteroid's trajectory to watershed moment for planetary defense. However, kinetic impactors have significant limitations. They require years of advance notice to be effective, as the slight orbital changes need time to translate into meaningful distance from Earth. Additionally, larger asteroids, or those spotted too late, would require multiple perfectly executed impacts to achieve sufficient deflection. A risky proposition when Earth's safety hangs in the balance. When kinetic impactors aren't powerful enough, or when time is critically short, nuclear devices might become humanity's only viable option. Unlike the Hollywood portrayal of planting bombs deep inside asteroids, real nuclear deflection would involve detonating the device near the asteroid's surface. This would irradiate one hemisphere with intense X-rays, causing the rocky surface to violently vaporize in microseconds. The resulting debris stream would act like a rocket engine, pushing the asteroid in the opposite direction. This approach delivers significantly more energy than any kinetic impactor, potentially saving Earth from impacts that would otherwise be unstoppable. However, the topic remains controversial. The 1967 Outer Space Treaty prohibits deploying nuclear weapons in space, and the political implications of launching such devices, even for planetary defense, make real-world testing virtually impossible. This has forced scientists to find creative alternatives. The inability to test nuclear deflection strategies directly creates a significant scientific challenge. Until recently, researchers relied primarily on computer simulations to predict how asteroids would respond to nuclear blasts, but simulations are only as good as the physics understanding programmed into them. This virtual approach faces numerous complexities: tracking individual X-ray photons penetrating asteroid surfaces, modeling shockwave propagation through varied materials, predicting fragment trajectories, and accounting for the vast scale differences between microscopic interactions and asteroid-sized bodies. Additionally, asteroids come in remarkable variety, from solid monoliths to loosely bound rubble piles, held together primarily by weak gravity. Each would respond differently to nuclear deflection attempts. Without physical experiments to validate simulation results, significant uncertainties would remain about the effectiveness of nuclear deflection techniques in real-world scenarios, making it difficult to deploy with confidence during an actual emergency. Two groundbreaking laboratory experiments are finally providing real-world data on nuclear asteroid deflection. At Sandia National Laboratories, scientists use the Z machine use a massive 3-story electrical facility, packing the power of 1,000 lightning bolts, (MeTows) to recreate nuclear blast conditions in microseconds. In a 2023 experiment, researchers developed an X-ray scissors technique that suspends miniature asteroid samples on thin aluminum foil within a vacuum chamber. When the machine fires, the foil instantly vaporizes while X-rays blast the targets, successfully pushing them backward at 160 miles per hour. Meanwhile, at the University of Rochester's Omega Laser Facility, another team directs powerful lasers at meteorite samples to generate nuclear explosion-like X-rays. By conducting hundreds of tests on various materials, they're gathering crucial data about how different asteroid types would respond to nuclear deflection. Together, these complementary experiments are transforming theoretical models into evidence-based defense strategies. These pioneering experiments have confirmed something foundational: X-rays from nuclear explosions can indeed deliver sufficient force to move objects in space, validating the basic physics behind nuclear asteroid deflection. However, researchers acknowledge this is just the beginning. Future work aims to test a wider variety of asteroid-like materials, particularly carbon-rich and more fragile compositions commonly found in near-Earth space. Scientists also hope to obtain genuine meteorite samples for testing, providing even more accurate data. The ultimate goal is to feed these experimental results back into computer simulations, creating increasingly reliable models that could guide actual planetary defense missions if needed. While nuclear deflection remains a last resort option, these experiments provide valuable assurance that humanity isn't defenseless against cosmic threats. Though challenging and sometimes controversial, this research represents a crucial insurance policy for our planet's future safety. In the cosmic shooting gallery of our solar system, asteroid impacts represent a rare but potentially catastrophic threat. Unlike earthquakes or hurricanes, asteroid impacts are the only natural disaster humanity can actually prevent with enough warning and preparation. The scientific journey from Hollywood fantasy to laboratory reality has been remarkable. Researchers have moved from theoretical equations to physical experiments that validate nuclear deflection as a viable last resort option. While these tests use sophisticated devices like the Z machine and Omega Laser Facility, rather than actual nuclear weapons, they provide crucial data needed to protect Earth should the unthinkable occur. As one scientist aptly put it, these experiments represent taxpayer dollars at work, a global insurance policy against extinction-level threats from space. Want to learn more about protecting Earth from cosmic threats? Subscribe to this channel for future videos about space science and planetary defense. Visit NASA's Planetary Defense Coordination Office website to see how astronomers track potentially hazardous asteroids and support organizations working to expand our asteroid detection capabilities. Share this video to raise awareness about this fascinating field of research. The more people understand about planetary defense, the more support these crucial scientific efforts will receive. Remember, like the dinosaurs, we have a space program and the technology to protect ourselves. Let's make sure we use it wisely. What other space topics would you like to see covered next? Leave your suggestions in the comments below.